If the end of the universe is a reset, then 12 trillion years from now, we might meet again. This isn't science fiction, it's a mathematical inevitability revealed by the Poincaré recurrence theorem. From childhood, we know that a shattered cup won't jump back onto the table by itself. Mixed milk and coffee won't separate automatically, and time cannot flow backward. Only when we grow up do we learn that this is the curse of the second law of thermodynamics, entropy increase. Everything in the universe is inevitably heading toward disorder and decay. But in 1890, a mathematician used pure mathematical logic to derive a conclusion that shocked both physics and philosophy. Given enough time, that shattered cup, due to the randomness of atomic motion, will eventually reassemble perfectly. Given enough time, all chaos in the universe will reset, and you too are made of countless atoms. After a long era of death and silence, they will recombine and you will open your eyes once again. This is the famous Poincaré recurrence theorem. Hello, Earthlings. I'm Lao Ma. Next, let's work through this eternal cycle that spans the lifespan of the universe. To understand this seemingly insane theorem, we first need to know the man behind it, Henri Poincaré. Even if you don't like math, you've probably heard of the three-body problem or the butterfly effect. That's right, Poincaré was the first to discover that the three-body system is non-integrable, effectively founding chaos theory. At the end of the 19th century, physics was shrouded in despair. Clausius's heat death hung over the world like a dark cloud. If the universe is an isolated system, entropy will keep increasing until all energy is exhausted, temperatures equalize, and the universe becomes a dead, stagnant pool. No life, no change. Sounds like the end of the world, right? But Poincaré didn't see it that way. As a mathematician, he wasn't concerned with thermodynamics' macroscopic descriptions of heat. He cared about the system's most fundamental microscopic mechanisms. In 1890, while studying the three-body problem, he proved a theorem crucial to dynamical systems. He found that as long as a system satisfies two seemingly simple conditions, first, the system's energy is conserved, second, the system is confined within a finite space, then no matter how complex the motion of its particles becomes, the system will eventually return arbitrarily close to its initial state, not possibly, inevitably. Like this chaotic steel ball experiment, as long as the boundaries remained fixed and energy conserved, after countless random collisions, the balls will miraculously return to the corner, perfectly recreating their initial configuration.
To prove this, we need a slightly hardcore concept, phase space. Stay with me. To describe your current state, we need the position and velocity of every atom in your body, an astronomical amount of data. But mathematicians compress all of this into a single point in a high-dimensional space. As time passes and atoms move, that point traces a line called a phase trajectory. Poincaré then used Liouville's theorem. Simply put, it says that motion in phase space behaves like an incompressible fluid. If that sounds abstract, here's an analogy. Imagine phase space as a finite-sized room. The system's state is a fly endlessly flying inside. The fly's path never overlaps and never stops. So what happens if time is infinite, but the room is finite? The fly can't keep flying to new places forever. Eventually, it must return near where it has been before, infinitely many times near its starting point. What does this mean? It means that macroscopically, the system, the universe, must return to previous states. This discovery slapped the great thermodynamicist Ludwig Boltzmann in the face. Boltzmann defended atomism and entropy increase his entire life. He believed particles only grow more disordered. Broken mirrors never mend. but a young mathematician named Zermelo invoked Poincaré's theorem and challenged him. If the world is a mechanical system of atoms, then entropy must eventually decrease. So either your entropy law is wrong, or atomism is. This plunged Boltzmann into deep self-doubt and despair, a tragedy in scientific history. But modern physics tells us neither was completely wrong. The truth is, entropy increase isn't absolutely irreversible. It's overwhelmingly probable. Like buying lottery tickets. Entropy says you'll almost certainly lose, but Poincaré says if you play long enough, trillions upon trillions of years, you must win once. For the universe, that jackpot is chaos suddenly becoming order, shattered cups reassembling, air molecules gathering in one corner, decayed organic matter randomly recombining into living bodies. This doesn't violate physics, it's just absurdly unlikely. But in infinite time, improbability becomes inevitability. You might now think, so I don't need to fear death? Not so fast. 12 trillion years is just a small milestone. By then, all stars will have burnt out. Even complex atoms like carbon and oxygen will decay. Life will have vanished long before. Yet this is still nowhere near the true Poincaré recurrence time, which is billions upon billions of universe lifetimes. How long is that? It's called the Poincaré recurrence time. For a few atoms, it may be seconds. For just 1 cubic centimeter of gas, it's already astronomical. For the observable universe, physicist Don Page calculated it as 10 to the power of 10 to the power of 10 to the power of 2.08 years. If you wrote that number out, even if each zero were the size of a proton, the universe couldn't contain it. Compared to that, our universe's age of 13.8 billion years isn't even a blink. It's practically non-existent. So in any future humans can comprehend, entropy still reigns. We age, stars die. The miracle of recurrence hides beyond eternity itself. But here's an even more disturbing philosophical question. If Poincaré recurrence is real, then in infinite time, atoms randomly form everything. Mostly chaos, but occasionally a brain. A brain identical to yours, with your memories, childhood joy, tonight's dinner, watching this video. This is the famous Boltzmann brain. On recurrence timescales, forming a single brain is far more likely than forming an entire ordered universe. So what are you? A real human in the 21st century? Or a Boltzmann brain floating out of the void billions of trillions of years from now? It sounds insane, but you can't logically disprove it. And there's an even deeper issue, identity. If atoms recombine into you again, with your genes, memories, emotions, is that still you? From materialism, yes, same structure, same consciousness. But subjectively, there's no sense of return. Death feels like a skipped frame. From your perspective, it never existed. You close your eyes, The universe lives and dies countless times. You open them again as if only an instant passed. This echoes Nietzsche's idea of eternal recurrence. He asked, if a demon told you your life would repeat endlessly, every joy, every pain, every breath, would you worship him as a god or collapse in despair? Poincaré's theorem seems to give this idea physical plausibility, but there's a final twist. Poincaré recurrence requires a confined system. Modern astronomy shows the universe is expanding, accelerating. If expansion continues forever, space becomes infinite. Particle encounters drop to zero, and atoms drift apart forever. This is the Big Freeze or Big Rip. It sounds tragic, but it frees us from eternal recurrence. We may truly have only one life, one unique performance, and that may be the most scientific kind of romance. Because time cannot rewind, because recombination is vanishingly unlikely, every breath, every love, every pain matters. Not a copy in an endless loop, but a single echo in all of time. So cherish this moment, live in the present, seek the universe's answers at the edge of science. Thank you for wishing, like, comment. See you next time.